Hello. In today's video, we'll be taking a look at this particle equilibrium problem. We have a classic traffic light problem where the light is being supported by two cables. We need to find the force developed in each cable in order to keep the traffic light in equilibrium. Given the maximum force that the left cable can withstand, we also need to determine if the cable will support the weight or not. We start this problem by drawing a free body diagram of all of the forces acting on the traffic light. First is weight, which acts straight down in the negative y direction. I'll denote this as mg. The other two forces are the forces from each cable, so force BA and force BC. Since we know the angles that the force acts at, we know essentially the direction that they'll act along as well. So for example, this is FAB, and it's going to act at an angle alpha from the horizontal. And BC right here, same idea, it's going to point along this way, and it's going to act at an angle theta. Since this is statics, we know that the traffic light is not moving, so the forces in the x and y direction need to sum to zero. We can write two equations, sum of the forces in the x and y directions to be zero to solve for the unknown cable forces. So I'm going to start with the sum of the forces in the x direction is zero. So we're going to get FBC times cosine of theta, right? Because that's our horizontal projection of FBC. And then we are going to do minus FAB cosine alpha, because that is going to be this horizontal projection of this force. And this has to sum to zero, right? Because the traffic light, it's hanging perfectly still. It's not accelerating to the left or right, so the horizontal forces have to equal to zero. So this is going to be equation one. I'm going to do the same thing, but now force in the y direction has to be zero. So let's do FBC sine theta plus FAB sine alpha, and these are both positive because they act in the same way. That's the vertical projection of the force. Then minus mg, right, our weight force, has to equal zero. So this is our equation two. So we have two equations and two unknowns. So this is enough to solve for the unknown variables, these force values that we want. So let's just start with equation one. Let's solve for FBC. We get that FBC is going to be FAB cosine alpha all divided by cosine theta. So now that we know FBC in terms of FAB, we can plug this back into equation 2, which essentially eliminates down to one unknown, and we can solve then directly for FAB. So by doing this, we're going to plug FBC in here, so we're going to get FAB cosine alpha over cosine theta times sine theta plus FAB sine alpha minus mg is zero. Doing a little bit of algebra, cleaning this up, we know sine theta divided by cosine theta is just tangent theta. So this becomes FAB cosine alpha tangent theta plus FAB sine alpha. And I'm actually going to move mg over, add mg to both sides, has to equal mg. Now we can see that we can just factor FAB out from these terms. So we're going to be left with cosine alpha tangent theta in this term, and then we're just going to be left with sine alpha in this term. This has to equal mg. So to solve for the force acting in cable AB, all we do is simply just divide mg by this part of our expression here. So we're going to have FAB is equal to mg divided by cosine alpha tangent theta plus sine of alpha. So using this equation, we can directly solve for FAB now. So we're given that it weighs 20 kilograms and gravity is 9.81 meters per second squared. So that's 196.2 newtons of force in the numerator. And then our denominator is going to be cosine of alpha. We know alpha is 42 degrees times tangent of 35 degrees. It's going to be plus the sine of alpha, which again was 42 degrees. That comes out to 1.189 in the denominator. So we divide the two, we get that FAB has to equal 164.9 newtons. All right, so now we need to go and plug back in FAB back into this equation up here, right? Because we know FBC in terms of FAB You can plug in FAB, this value, into any of these other equations and still get the right answer for FBC. It's just easier to do it because it's pretty simple. We don't have to do any more manipulation. So plugging in to that equation up there that we solved for at the beginning, we get that FBC is going to be FAB times cosine alpha. Alpha was 42 degrees, just one more time, and then divided by cosine theta, which is 35 degrees. So when we do that, we get that FBC is 149.6 newtons. So that is the answer to part one. We solved correctly for two forces in the cables. Now part B was saying that the left cable can hold a maximum of 3,000 newtons will the cable snap. So the left cable in this case is going to be force AB. We can directly look and see that the force acting in it is 164.9. So that is much lower than the maximum. So it is very safe. It is most definitely going to hold. So no, it will not snap. So yeah, this is how you do this simple traffic light particle equilibrium question. I hope this was helpful. Thank you for watching.